everybody. Today, I'm going to be teaching you guys how to go to a vertex form using a method called completing the square. Now, this is something that a lot of people often struggle with, and the reason why is because there's a lot of these steps that seem unnecessary, but in the end, after looking at it and looking at a bunch of examples, you finally understand it. So I'm just going to get straight into it and tell you guys about each and every single step. So let's start off with completing these quadratic equations into vertex form. And let's just first understand what these two are. Now, vertex form is a form where you can access the vertex, which is the minimum or the maximum of our parabola. So here it's a minimum, and here's a maximum. Vertex form allows you to just access that vertex faster than something like this. Like, where are you going to get the vertex here? And that's why it's better in this case. Now, completing the square is the actual process of getting towards this vertex form. So, another thing that is worth mentioning is that this value, depending if it's positive or negative, actually determines the shape of your parabola. But this is only including in vertex form. So let's say this is how vertex form looks like, right? I'm just going to give a quick example. Something like this, right? Now, in this case, our vertex is 2, 3. And the reason why is because this negative, it just it just gets um it just gets inverted. And the reason why is explained a little bit more in functions, but the shift is not actually a like possible thing. It actually goes to the right, which is why we do 2, 3. Now, in this case, since it's positive, a way you can remember this is a smiley face. The parabola is like a smiley face because it's positive, right? And that means this is a minimum. So in this case, our quadratic is a minimum of 2 and 3. Now, let's actually get on to some quick examples and how to complete the square. Now, our first step here that you must always initiate is to factor the first two terms by coefficients of term 1. Now what this means is that this is our term 1, and we need to factor all of this by that same thing. So what essentially happens here is that we factor it out, getting y equals 3. Then we get, so after we factor this out, we get x squared here. Negative 18 divided by 3 is minus 6x. And that's the first thing we do. And we close that bracket up, and we keep the 23 here. Now from here, you might be wondering why we don't factor out the x. And the reason why is this next step. And that is term 2 within bracket. Add, then subtract by term 2 divided by 2 squared. So what this looks like is that this is our term 2 inside the bracket. So negative 6 divided by 2 is going to be 3, and squaring that is 9. So y equals 3 x squared minus 6x. And we don't include the thing here. We don't include the variable. We just do plus 9 minus 9 plus 23. Now in this case, we can do something, the perfect square trinomial, which is something that you should have already known. And this gets us, we have to do that with this, which gets us 3x minus 3 squared. And then here we can multiply the 3 times the negative 9 and add it by 23. So this becomes plus 3 times negative 9 plus 23. And in that case, that becomes negative 4. So our total thing is going to be y equals 3 x minus 3 squared minus 4. So in this case, we inverse this and we take that. So it becomes negative 4 and 3. And in this case, asking if it's a max or min value. And since our a value is positive, we can imagine a happy face, and that means it's a minimum. Let's do one more example. This one is a little bit more tricky, but it's basically the same thing. So here, we factor out the first term, negative 4. Then 40 divided by negative 4 is negative 10x. Negative 10 divided by 2 is 5. Squared is plus 25 minus 25. And we keep that negative 5 out there. From here, we factor the perfect square trinomial. This gets us y equals negative 4 x minus 5 squared. And then we distribute this as the next step, which is negative 4 times negative 25. And then we take that remainder negative 5. Now this gets us negative 4 times negative 25 minus 5, which is 95, plus 95. And this is if you look, it's actually a negative, so that means it's a sad face, and that means it's a maximum. And this gets us, we opposite this, 595. And that is our vertex. Now let's do two more examples, and I'm just going to be doing these ones, since these ones are a little bit more different compared to these. So it's actually D and C that I'm going to be, D and F that I'm going to be doing. So the first thing you might understand here is that we can't really factor out that first term. So we just skip to the next step. In this case, that's x squared minus 5x. We do negative 5 divided by 2, and then we square it, which gets, negative 5 divided by 2 squared gets us plus 25 over 4 minus 25 over 4 plus 1. Now from here, we can factor it out as we can get x minus the answer, which is 5 over 2. And we can do negative 25 over 4 plus 1, which gets us minus 21 over 4. From here, it becomes 5 over 2, negative 21 over 4, and since the a value is positive here, it's a happy face, meaning that it's a min. Now here, there's a fraction, and I kind of want to let you guys do this on your own before I move on, so go ahead do that. Alright, so y equals negative 3 over 4. First we factor out that first term to get x squared, then we divide it, negative 2 divided by negative 3 over 4. What we get from here is 8 over 3. From here, 8 over 3 divided by 2 squared gets us plus 16 over 9 minus 16 over 9 plus 5. Y equals negative 3 over 4 x plus root 16 over 9 x plus 4 over 3 squared. And from here we do negative 3 over 4 times negative 16 over 9 plus 5. And that gets us plus 19 over 3. Opposite of that is negative 4 over 3 inside here. And here is our C, or our shiftwards upwards, and that's going to be 19 over 3. And from here, this is a negative, so it's a sad face, and it's a max here. So that's essentially how you do it, and now I'll be moving on to a couple of word problems that you guys understand the basics of this. So, a model rocket is launched from the roof of a building. Its flight path is modeled by h equals negative 5t squared plus 30t plus 10, where h is the height of the rocket above the ground in meters, and t is the time after the launch in seconds. What is the rocket's maximum height, and when does it reach the maximum height? So in order to do this, it's obviously asking us to complete the square. Whenever it's asking for anything maximum or minimum, depending on the quadratic, if it's like, since this is negative, it's gonna look like a little like that face. So from here, the maximum height is right there. Now we can do that by factoring out negative 5 first. (30 divided by negative 5, we can factor those first two. Plus 9 minus 9, you know the drill, plus 10. Then from here we can go h equals negative 5t t minus 3 squared as we do the perfect square trinomial method. And then we can simply multiply these out. Negative 5 times negative 9 plus 10, getting us plus 55. Now from here, our vertex is, we take the opposite of that. So 355. And since x here is t, it's 3 seconds and 55 meters. We can also further display this on our quadratic right here, where we can write 355.